Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with predictive analytics and that too coverage on simulation. In fact, we have already discussed couple of techniques in this particular unit, that is on predictive analytics, starting with association technique, causality technique, machine learnings and the data mining. So, this is also similar kind of predictive analytic structure through which you can understand the problems, get insights from the data, then develop a system through which you can do the predictions and do the kind of forecasting as per the problem requirement and the kind of management requirement. In fact, in a real life kind of situations and the kind of business situations, you will find there are lots of complexity, there are lots of dynamics, and with respect to availability of data and the kind of understanding, you have to develop a kind of systems or develop a kind of structures or develop a kind of algorithm through which you can do better predictions, better forecasting as per the management requirement. And in this context, simulation is a kind of effective tools or effective technique, and through which you can understand a particular business problem and then get better insights after the particular structure, and then you can go for the kind of prediction and forecastings. So, in these lectures we will highlight this particular component, that is the simulation, and then we will discuss how it is a kind of effective tool through which you can understand a kind of business problem and get the insights from the data, and then connect the particular structure through which you can do the predictions for the particular problem. In the simulations, lots of things are there, and it depends upon a kind of situation, because risks and the kind of uncertainty are always there in the in a kind of business process. So, that is why with respect to a particular structures or the kind of particular requirement, we have to develop a kind of system or structure, so that some kind of better prediction and some kind of better insights we can actually generate for the particular business problem or particular business requirement. In fact, in the simulations, so some of the things are uses of simulation, which I already in fact highlighted, and simulation process, then Monte Carlo simulations, then Quine's theory, and discrete event simulations, then advanced discrete event simulation. That means actually like data mining structure, simulation is not a kind of small component, it is a very big component and very attractive component for the kind of business environment or the kind of management environment, because most of the business problems and the kind of management problems are very dynamic with plenty of risks and uncertainty. So, with the simulations we can actually streamline the particular process and then develop a kind of system and the kind of structure through which you can actually control the problems, predict the problem as per the particular management requirement. So, that is how simulation, understanding the simulation and then use the simulation is very interesting for the kind of business analytics. And first of all, we would like to understand what is exactly the simulation, then we connect with structure through which you can get to know how simulation can be very effective tools for the business requirement or the kind of business analytics. And it is a process of molding reality to gain a better understanding of the kind of situation or system being studied. So, that means actually a particular system to be understand, to be kind of explored, but the thing is that you should first understand the particular structure through which actually the kind of structure you can develop. So, simulations means we like to know the kind of predictive structure with actual scenario. So, that means what is the actual fact, the real world scenario, and then how is the simulated structure. That means we like, again it is a kind of predictive structure and through a particular situations, and then we will compare with the actual structure with the predictive structure. So, more cost effective, and it is more dangerous to the kind of means less dangerous to the kind of environment, because it will give you some kind of setups through which you can monitor the process, and then kind of understand the kind of system through which you can actually predict the business requirement. So, it actually learns very faster, like support vector machines or random forest. So, it is actually more practical sometimes because of the kind of process which you like to develop, and the kind of technique itself, understanding the insights and get predicted environment as per the particular business requirement. And in fact, the particular tool does not require mathematical models or the kind of structures, but just have a simple kind of structure through which you can actually generate the kind of predictive kind of environment. For instance, actually a simple Excel Excel spreadsheet can help you to get the simulated results if you are actually know the particular fact and the kind of insights. So, that means again same things, you understand the problems, understand the insights, then connect a particular model and the kind of tools through which you can go for better prediction, better insights, and the better kind of management requirement, right. So, with this actually I like to highlight here the types of simulations with respect to performance, proof, discovery, entertainment, training, education, prediction. So, that means actually by the way, I mean it is a very effective tools as per the kind of dynamic business requirement and the kind of real life reality. Okay. So, the thing is that simulation process means understanding of the simulation process, and that to start with here the kind of model development, and then in the model development itself define the problems, or put the questions, or put the kind of structure as what is exactly we need, so that we can actually simulate accordingly. Until unless you clear about the problem, the kind of requirement, and the kind of need. So, we are not in a position to define the problem, and we are not in a position to simulate the kind of thing, so that the thing can be analyzed properly, or can be predicted properly. So, develop the conceptual model, and then generate the data. Means we need some kind of initial kind of insights, so that you can simulate for the future requirement. So, that means whatever techniques we have till now discussed. So, we need actually some kind of historical data, or some kind of or original insights, means actual insights or actual information, through which actually we develop a structure with different predictive analytics tools, and then we will go for the kind of new structure through which you can do the effective predictions and effective forecasting as per the particular business requirement. So, we are in the process simulation is a kind of structure through which we can get the kind of better structure through which you do the predictions as per the particular business requirement. Then as usual here the process is to develop the models as per the requirement, as per the data availability, data visualization, insights, then connect with a particular setups, then validate the particular setup, then simulate and analyze the output. So, this is how the it is not something new. So, it is also as usual the kind of structure through which actually you can actually develop, and then train, then test, validate, and then finally fix the particular structure as per the particular requirement. And simulation process altogether it is of three different stages. First stage more important is the model development, then model validations, then the simulation. It is like same techniques which we have discussed, like neural network, random forest, support vector machines, data mining tools like clustering, etc. So, in the model development, so the most important thing is the problem definitions, then develop the kind of conceptual model, and the model conceptual model it is not actually once you develop means it is a fixed, actually it is a kind of flexible, depending upon the structure, the requirement, it can change. Then final means it is a kind of continuous search process altogether. So, we are doing the kind of structuring, restructuring, testing, retesting, validating, revalidating, then finally fix up a kind of structure through which you can have a better system, and then we will do the kind of prediction as per the particular requirement. So, what I have mentioned earlier. So, the problem definitions, develop the conceptual model, then have the data, and then connect with a kind of structure through which it is not necessarily the computer, some structure through which actually you can actually generate the particular insights. Then model validations, that in the kind of quantitative comparisons, then sometimes you can actually connect or validate through experts opinions. And because we have a kind of qualitative forecasting structures through which actually we can quantify and develop a quantitative models with the help of existing information or actual information. Then numerically or in the modeling structure you can also validate, and then again still to make more effective, more efficient, you can also connect with experts opinion, and then finally simulate and then analyze. So, there are lots of again process, DOE, replication, that is a design of experiments, then data collections, storage and organization, then finally you can analyze the particular process. And Monte Carlo simulation is one of the such kind of structure through which we can do the simulations, and then means with the actual information we get little bit insights and develop the kind of model and generate or simulate for the future requirement. So, ultimately again, so every times there is a input kind of things, and then the kind of response variable, the target variable, that is the output to need to be actually predicted, and for that actually we are looking for a kind of structure or kind of algorithm or system through which we can actually simulate the future requirement of a business. So, random variables usually technically used for the kind of means a kind of probability distribution structure through which you do the prediction, and solution is a distribution of possible outcomes that can be generalized statistically. And this is a simple example, and we have a number of patients, that is with respect to frequency and the kind of charges. So, patients are paying, and they are so is a 20,000. So, it is at 10 and then 30,000, then 20, like that we have a plenty of data, and then just you plot, and then you can get a kind of insight. And the idea about this plotting actually to get to know a particular distributions. Now, one of the basic requirement of simulation is to connect, since it is with respect to risk and uncertainty, then obviously two major components for simulation for this particular predictive analytics is the probability and probability distribution. We have already gone through so many distributions, starting with binomial, Poisson distribution, normal distributions, geometric distributions. So, like that uniform distribution. So, we have lots of distribution. Generally the simulation is actually done through the particular distribution. So, having a particular structure or actual information of a particular problem. So, we like to first get insight and understand the system, and then check how these informations are actually fitted with a particular distribution. Once you pick up a particular distributions with respect to the actual availability or actual information availability, then easily through that particular distribution you can actually simulate for the future requirement. That is the basic funda about the simulation, and that is how first you understand. Then having the means the thing is that without having the initial insights or initial informations, that is how the data is a kind of one of the first hand requirement for the simulations, and then the kind of management requirement. So, so it has actually two step process altogether. First step, you having the actual information, you understand the particular structure, check how these information are connected with a particular distribution. Then using that particular distribution, you can simulate for the future requirement, and that to the kind of management requirement or the problem requirement. So, this is another way of visualization. So, it is a kind of so that means here we like to have a payment structure, and some are paying, not paying, and then we have a we like to know how much probability is for the paying case and non paying case. So, this is a simple case of structuring. So, I will take you to a kind of an Excel sheet and show you how once you get little bit insights and little bit structure, how simulation can help you to generate the kind of feature requirement or the kind of problem requirement or the kind of management requirement. So, here it is another kind of example, similar kind of example with more features and more variables, and here the payment structures, then this is with respect to payment, then die totals, charges, how much payment with a different kind of clustering. And then again what I I have suggested earlier, that with a particular informations with a particular item. So, you can first check the kind of means visualize first, check the particular distribution, then again use this particular distribution for the simulation. It can be in a kind of bivariate setup, and it can be with a multivariate setup. Since we are now connecting with payment with a number of trials, so that means it is a two variable case, we can plot and then you can check, but when we have a multiple kind of structure, then we can mathematically check and connect a models, and then finally you can predict the kind of requirement, right. So, this is how the kind of simulation structure, and likewise so this is how the analysis. So, once you get some kind of insights, then obviously you can actually develop a structure through which you can do the kind of predictions and do the kind of simulation. So, simple there is a Quine's theory through which actually you can also do the similar kind of prediction and similar kind of simulation. So, here it is a question of means to understand this particular technique typically. So, we need actually understand the particular system like customer population, then it may be finite and infinite, then arrival process. So, that means we need actually the kind of requirement. So, once we know the requirement, then we can follow the kind of particular structure through which you can do the simulation. So, in this case the best the particular system is followed by a Poisson distributions, and through Quine's theory. So, you first identify the kind of a requirement, then we the particular theory has a different kind of model. So, this is what the usual model. So, the simply actually to find out the capacity utilization, which is actually percentage of time the server the busy with respect to that particular problem. So, then we like to find out the capacity utilization, which actually the ratio between mean arrival rate by mean service rate, and again. So, with respect to some mathematics, we can calculate the particular system. Of course, actually when we do for more kind of future requirement and the kind of simulated values. So, manually it is not possible, but just we have to follow the kind of distribution and the kind of structure through which actually we just get connect with inputs, and then the kind of distributions, and after that it will help you to generate the simulated results as per the particular problem requirement and the kind of business requirement. So, in this case the means obviously what I mentioned the objective must be very clear actually. So, if you do not know the kind of response variables or the kind of objective requirement and the kind of attributes through which you can predict the response variables or simulate the response or the kind of objective. So, then you are not in a position to do the kind of analysis. So, that means we technically get to know the insights. First you understand the insights, the problem structure, the kind of objectives, then with the help of availability and the kind of understanding, you can develop a system and then develop a kind of simulation through which actually you generalize the problem as per the particular requirement and the kind of management requirement. So, this is similar kind of problems with the different understanding and different kind of structuring. So, that means technically we have already discussed the Monte Carlo simulations and the Queen's theory through which you can do the simulation. That means, these are the different process through which you can understand the problem, then develop a structure and then go for the kind of simulation, the kind of future forecasted requirement as per the management need. And the third kind of structure in the simulation is called as a discrete event simulation, and this is a basic simulation model. So, which there is a kind of objects that flow through the system, and it is again through Queen's theory, like entities where they are waiting for a kind of for a service, and obviously, so there are certain attributes through which actually we like to actually understand the problem and then get the insights for the kind of simulation requirement. And so these are all basic understanding about this discrete event simulation. And what I will do actually, I will means again, so in order to understand the particular structure, so I will take three variables, and here the three variables are sales, cost and benefit, and with a particular understanding and particular structure, and we like to check how simulation can generate certain kind of future requirement as per the problem need and business need. And with this whatever techniques which you have already highlighted, and that will be connected with the kind of structure here to understand the basics. And here the structure which I like to highlight is with respect to sales, cost and benefit. So, that means technically there are three variables, and as a result, so we like to know how the simulation can be done. So, with respect to what, and let us go to the particular Excel sheet, and in the Excel sheet we have actually what I have already highlighted. So, we have actually here three variables, sales, cost and benefit, and then we like to actually develop a simulated results with respect to these variables, and then that means any variable can be actually response, and obviously there should be a logical understanding or logical connection through, means the particular structure which you like to develop has a kind of meaningful interpretation or meaningful requirement, then simulation will help you. Otherwise, these are all actually mathematical tools. If you connect differently or without any logic or without any kind of theory, then the prediction structurally not actually the kind of as per the management requirement and the kind of problem requirement. So, that is how actually having the information and understanding the problem is the first hand requirement for any kind of predictive analytics. So, once you understand, once acquainted with the particular structure, then you connect the actual insights and then get the inbuilt insights, then finally go for the kind of prediction and the requirements. So, now in this case we really like to go for simulation, that we have a lots of simulation techniques. So, we like to, because one of the most important technique is the Monte Carlo simulation, and we like to use that particular technique through which you generate the simulated figure, and you see basic requirement is here. So, there are sales, cost and benefit and some data which we have highlighted here, and then again you can actually develop the simulation of a particular problem with any softwares which like which you have already highlighted. So, you can go through means you can solve the problem by MATLAB, you can go solve the problem through R softwares, and you can go through kind of other software like SPSS, Startup. And again in this case actually we are using here Excel Start, which is a similar kind of package whatever we have already highlighted, and same way we will also highlight this problem and get to know how simulation can help the particular business process to get some kind of effective kind of scenario through which you can do the management decision. And in this case going through this data for the particular simulation package, so it will be appearing in the advanced features, and here we have plenty of tools like conjoint analysis, decision a time series analysis, Monte Carlo analysis. So, likewise we have a couple of advanced analytics tools through which you can analyze the problem, get insights, and then think about the prediction about the future. So, since we are our focus is on simulation, that Monte Carlo simulation. So, you just click here, and then since there are 3 variables. So, one of the first hand requirement of this particular structure is to define a particular distribution. That what I have already mentioned, that understand the problem, then connect that problem with a particular distribution. So, connect with a particular distribution means it is not arbitrary choice, you must have a kind of insights to check that whether this particular problem is fitted with binomial distribution, Poisson distribution, or normal distribution. And let us assume that this is connected with a normal distribution. So, so first we check the kind of structure. So, let us start with the particular cells value first, and then go to the advanced feature, then go to the define distributions. So, which I have defined here actually normal distributions. Okay. So, put OK, then again go to the cost side, and then again go to the Excel start, advanced features, choose Monte Carlo simulations, again define the distribution for the cost, and again we allow for the normal distributions, and then finally you go to the benefit, which is actually our requirement, then again go to the Monte Carlo simulations. So, now here we like to actually we like to have a define the kind of result variables, because we like to actually here simulate the benefit structure with respect to sales and cost. And again, so we define structure, you have to pick up a particular setup, and finally you go to the Excel set, Excel start, and then advanced features, again pick up the Monte Carlo simulations, and then run the model. So, that means what we have done, we have actually system here benefits with respect to sales and cost, and we like to generate the simulation for the benefit structure, and that too with respect to sales and cost, and for that we have actually used the normal distribution structure, and as per the normal distribution requirement. So, we need actually population parameters, that is the mean and standard deviation. So, giving a mean and standard deviations as a kind of proxy which you can assume, or we can actually get through a kind of market informations, and the kind of expert structure, and then expert structure through which we can actually design and then go for the kind of simulation. So, now you just put OK, and then it will be run the models, and finally you will get the kind of simulated value, and this is what the simulated value see here, and this is how statistic and cost and sales, and these are all again descriptive statistics starting with number of observations and minimum and maximum. In fact, in the simulation table we put 1000 structure, that can be actually changed, you put 5000 or 1 lakh. So, automatically the simulated figures will be coming. So, these are all various descriptive statistics. So, this is again like previous discussion about the random forest, support vector machines, and the data mining. So, descriptive statistic will be the kind of mandatory requirement to report, to know, understand the actual insight and the actual kind of scenario. Then the particular technique can be actually developed and then compare with the actual scenario with the predicted scenario. So, descriptive statistic will help you to understand the actual fact and connect with a particular distribution, particularly for the simulation. Then it will help you a lot to go for the means choosing a best distributions then for simulation. If the choice of particular distribution is wrong, then the simulated figure will be also wrong. So, as a result the management decision cannot be effective. So, that is why this should be actually first connected and understand, and this is how the kind of cost and cell structure, and this is how the box diagram will give you some kind of indication about the model validations, and this is how, since we choose actually normal distribution, and this is how the cost structure, and this is how the cell structure, and it is normally distributed, and as a result the most important thing is actually the simulated results. This is what the simulated results, and we simulated for benefits, that too with respect to sales and cost, and the simulated figures are available here. So, these are all actually simulated figures. Okay. So, let us see here. So, this is actually particular distribution which is followed by normal distribution, and this is what the result variable. So, that means technically, so the simulation generate now it's these are all future requirement, and this will be available for actually 1000, because we ask the software to run the model for 1000. So, if you change that particular structure, then if you choose 500, then it will give you 500 simulated figure. If you choose 1000, it will give you 5000 1000 simulated figure. Again you see here. So, this typical understanding here is that if you go to the first and data, so it is with respect to cost and sales, and that to the kind of benefit CS. So, technically it is the benefit which depends upon sales and cost, and what we have done actually, we understand first the cost structure, connect with a particular distribution, and sales structure which you can understand and connect with a particular distribution. Then now finally benefit is predicted and simulated with the help of cost and sales, where we are assuming a normal distribution structure, and then one of the most important thing or requirement is here to fix the or assume a particular structure, that is the requirement of parameters value, that is a kind of for the normal distribution we need actually mean and standard deviations. So, once you get mean and standard deviations, and then the kind of variables insights and the kind of variable understanding, then you can actually simulate for for the requirement problem requirement. So, that means in this case here the kind of benefit is actually predicted with the help of cost and sales, and since we have fixed the distribution, fixed the particular structure. So, the software will help you to give you the forecasted figure of benefits, that too with respect to cost and sales, that too for future 1000 units altogether. So, now if you change the particular simulated requirement, then obviously this value can be actually also generated more. So, this is actually big kind of structure. I am just highlighting so that you can see more effectively. So, these are all actually simulated figures. Okay. So, these are all simulated figures. So, this is starting with the first unit. So, this is okay one. Okay, this is okay. So, this is how the past units. This is what the simulation, and in the simulation this is the main results through which we are actually looking as per the particular problem requirement and management requirement. And so, it is for 1000 unit, because we have fixed the particular software or allow the softwares to generate simulation figure for 1000 unit. If you change, then it will give you, means if you change to 2000 or 3000, then again you will get simulated figure of 3000 items. So, as a result what we actually try to address here, that simulation is a kind of effective tool through which you can get some kind of structure to understand the insight, and define a kind of structure or develop a kind of structure for the future requirement. And obviously, over the time you can actually compare with the actual structure or actual fact, but means it is a part of the game, and simulated figure is always for future kind of requirement. That means, in this context, so we have actually predicted for 1000 units forecasted structure, but how is the actual structure happening. So, that need to be compared, and then finally, you can check the validations. That means, if your problem understanding is very clear and the choice of the distribution is very clear, then the difference between the actual happenings and the kind of simulated happenings or predicted happenings may not be actually highly distant. So, so the effective prediction and effective simulation, we can call that effective prediction and effective simulation for the particular business requirement, if the difference between the actual and predicted will be minimum as much as possible. Actually, that is how we most of the techniques we use actually the kind of prediction indicators, various prediction indicators, just to compare the actual scenario and the predicted scenario, and then check what particular methodology or framework gives highly minimum kind of bias, so that we can declare that the model is very effective for the particular problem and the kind of prediction and the kind of management requirement. So, these are the kind of same things which you have already highlighted, and this is how the cost and sales benefits, and that is the correlation matrix. So, in fact, the correlation says that cost and benefits are highly correlated, but sales and cost are low correlated, and again benefit and sales is having high correlated. Anyway, so our job is here is to predict the kind of benefit structure with respect to sales and cost. Of course, when we analyze this kind of problems, in between there may be certain issues with respect to relationship between independent variables, the kind of multi-coordinate issue, the kind of data issue, the kind of model issue. So, what is actually the requirement that you understand the data structure, then understand the problem theoretically, logically, convince as per the particular requirement, then you connect a particular models or choose a particular model as per the particular problem structures with respect to variables availability and the data availability, then come with a kind of a model structure, and we can validate after that, and finally fix the kind of model which can give you effective prediction and effective kind of requirement, and which is actually the kind of management requirement, and then accordingly we can go for some kind of effective decisions. So, that means there are a number of areas where simulation can be applied, and that is actually that is how it is very useful for the kind of problem requirement and the kind of management requirement. And altogether in the predictive analytics we have discussed lots of techniques. In fact, particular technique requirement is different, and means sometimes we can choose a particular technique as per the problem requirement. So, altogether we get to know various tools, predictive analytics tools, through which some management problem can be analyzed, can be predicted, and accordingly management decision can be taken into consideration. With this we will stop here. Thank you very much. Have a nice day.